All right, today we are working on I-5, absolute value, functions. As you work today, you're going to need one highlighter, or if you want to use one colored pencil, you can do that. And you are going to need 3 graphs. 1, 2, 3. 3 graphs, eventually. So set those off to the side. Okay, remember absolute value. This goes way back to Unit A. Absolute value is our distance from 0. Which means that it's always positive. Okay, so for example, if I have an absolute value of 3, how many steps away from 0 is 3? Well, 3 is 3 steps away from 0. Okay, the absolute value of negative 2. How far away from 0 is 2? Negative 2 is 2 away, so positive. Okay, but then if I do 3 minus the absolute value of 2 minus 6, okay, 2 minus 6 is negative 4, and then the absolute value of negative 4 is 4. So now if I bring down that 3 minus 4, the answer is negative 1. So sometimes we can get an answer that involves an absolute value, and the answer is negative 1, but the actual absolute value itself was a positive 4. So that's okay if in the end we have negative 1, especially if things on the outside. All right, so here we go. We're going to start with our first one. This is called a parent function. Okay, a parent function really just means that it's the original. Okay, so our parent function is just y equals absolute value of x. So for this one, we're going to just make a table, x, y. And we're going to do negative 3 all the way up to positive 3. So negative 3, negative 2, negative 1, 0, 1, 2, and 3. Okay, to get our y, we're taking the absolute value of x. So I'm thinking, what's the absolute value of negative 3? Absolute value of negative 3 is positive 3. 3 away from 0. How far away from 0 is negative 2? Negative 2 is 2 steps away from 0. Negative 1 is 1 step away from 0. 0 is right on 0, so that's absolute value is just 0. Absolute value of 1 is just 1. Absolute value of 2 is 2. And the absolute value of 3 is 3. So we're going to glue in your first graph here. We're going to just put it here. Don't glue in your next graphs because we do have some information to write in. Okay, so we're gluing that in. And then we're going to plot these points. So our first point here is negative 3, 3. So remember that's left 3, up 3. And we have negative 2, 2. So left 2, up 2. Negative 1, 1. So left 1, up 1. 0, 0, which is right in the middle. 1, 1, which is right 1, up 1. 2, 2, right 2, up 2. And 3, 3. So as we take a look at this, this actually makes a V shape, which I think is really nice because it's called absolute value. So value has that V, so it gets a nice V shape. So as we take a look at that, it kind of looks a little bit like a parabola, but a parabola was a U shape. It curved at the bottom. This one has a point. So even though it has a point, it still has a vertex. Now, it could look like an upside down V. In this case, that vertex is talking about the vertex here. The vertex here would be a maximum. If we go this way, normal V, this would be a minimum, this would be a low point. Okay, and the vertex is always that point where we are at that point of 0. So it's always where the absolute value equals 0. So this is where I'm going to use my yellow colored pencil today, because we're always looking on this inside part of this absolute value to find that vertex. This one was easy because it was just x, so to find it when it was 0, we just needed the inside to be 0. So our vertex was at 0. All right, we have one more thing that we're going to add to our notes here at the bottom, and then I'm going to go to the next page. Is when we look at this, remember we have the parent function. This is the original. Now we're going to be changing it. So if I have y equals, our standard form here starts with a, absolute value, so straight lines, x plus h, straight line, plus k. Now this tells us some information based on just this equation. A first tells us if it's wide or narrow. So is it going to be wide? That means it's opening up. Wide would be like it's opening up really wide. It would be obtuse. Narrow is really narrow. Maybe acute. Okay, next up we have h. This h inside, because it's with the x tells us to go left and right. Now this is actually backwards to what we're used to. If it's positive, that's actually going to tell us that it's going to the left. If it's negative, it's telling us it's going to the right. All right, and then we have this k. K, because it's on the outside, it's telling us it goes up and down, and this one does follow our rules like normal. Positive means it's going up. Negative means it's going down. All right, so make sure you have that all written down. Remember, if you need to be pausing, rewinding, do that. All right, we do have 2 more examples. All right, so here we go with number 1. Okay, number 1, we have f of x equals 2 times, oops, straight line there, x plus 4. So this 2 tells me it's going to be wide because it's bigger than normal. It's double the size. And the 4 tells me it's going to go, because it's positive, positive actually tells me it's going to go left 4. Okay, so first thing we're actually going to do here, remember, is to find the vertex, we always look at this absolute value. So our first step is to find the vertex, just like it was when we did our quadratics. Okay, so our vertex here is when the absolute value of x plus 4 equals 0. We're always looking for that equals 0. Okay, so if I solve that, x plus 4 equals 0. To undo this plus 4, I'm going to subtract 4. If I do it to one side, I do it to the other side. X equals 0 minus 4 is negative 4. So now I'm going to make my table. And we do it just like how we did our parabolas. So in the middle of my table, I'm going to put that negative 4. I might put it down one too many, sorry. And I'm going to think what comes above negative 4. Now, depending on you might put in negative 3, or you might have said negative 5. Either way is fine. Okay, and then above negative 3 would be negative 2. Then if you count negative 2, negative 3, negative 4, next would be negative 5, and then negative 6. Okay, now in this next part we're using Desmos. So we need to write that kind of off to the side there, Desmos. And in Desmos we're doing 2, because that's what our function is, 2, and then an absolute value. We're going to do the parentheses for the x plus 4. And then the absolute value side. Okay, and we're putting in these numbers for those parentheses. So this is where we're going to take out our calculator. Almost said square root. Don't know why. Okay, I'm going to type this in first. So 2. Now absolute value is up here. It's these straight lines. So absolute value parentheses plus 4. Okay, and then if you want to hit that again, you can. Otherwise, it was ghosted in there. So, all right. So in that first one, we have negative 2. So we get out 4. All right, I'm going to delete the negative 2, put in negative 3. We get out 2. Now this is our vertex, negative 4. We get 0. Now just like our parabola, when I put in negative 5, it should be going back up. So yep, it hits that 2 again. And negative 6 should be 4. So it should have that matching, just like it was in our parabolas. All right, go ahead and glue in this one, whatever this one is. Okay, and then we're plotting those points. I need to pause to get that glued in, do that. So we have negative 2, 4, so left 2, up 4. Negative 3, 2. Negative 4, 0. Negative 5, 2. And negative 6, 4. That makes that V. Now I made a mistake earlier, which I always do with these ones. Okay, first off, if we go back, did it go left 4? Well, normally this point is at the origin, it's at the middle, so yep, it just went left 4, it didn't go up or down. This part I made a mistake. It actually gets narrower. I forget that, it's backwards of what I normally think. Okay, because it's rising twice as fast. So if it's rising quicker, it's going to be narrower because those sides go up faster. Sorry, my bad. All right, we have one more, number 2. Last one for today, we have h of x equals negative 3 times the absolute value of x minus 3 plus 4. Okay, what this is going to tell us, negative 3 tells us it's actually going to be an upside down graph and that it's going to be narrow. That part, if you don't know narrow and wide, that's fine. But this minus 3, because it's a negative, that negative 3 tells us it's actually going to go to the right 3. That's backwards of our normal. And this plus 4 actually tells us that it's going to go up 4. So from our origin, it's going to go right 3, up 4. So origin is our normal spot in our original graph. All right, first step here is to find the vertex. To find that vertex, we do the absolute value of x minus 3. We want to find out where that equals 0, always 0. Okay, so I solve that. X minus 3 equals 0. To get rid of a minus 3, we do plus 3. If we do it to one side, do it to the other side. 0 plus 3 is 3. All right, so as our table, we have x and y. 3 goes in the middle. Above 3, depending on how you count, you might say above 3 is 2, and then above 2 is 1, or you might say it's 4. I don't know, up to you. After 3 is 4, and after 4 is 5. So again, we're using Desmos here. So in Desmos, I'm going to write it underneath here. We're doing -3, absolute value, and then x, I'm going to do my parentheses, -3, absolute value, plus 4. Really important that plus 4 is on the outside. And I'm going to just say use Desmos. Okay, it's really important. Okay, there's a lot of functions happening here, a lot of things. So I'm going to type in this part first. -3, absolute value, that's these straight lines. Parentheses, -3, absolute value, plus 4. Plus 4 is on the outside. All right, so now I'm putting in these points. So first point I'm putting in is 1. When I put in 1, we get out -2. And put in 2, we get out +1. We put in 3, we get 4. Now we said this was the vertex, so hopefully it goes back to that 1. Put in 4, yep, we get 1. Put in 5, and we get out -2. Okay, glue in that last graph. Struggling. Okay. Okay, last graph here, we have 1, -2, so we're going to go right 1, down 2. 2, +1, so right 2, up 1. 3, 4, so right 3, up 4. 4, 1, so right 4, up 1. And 5, -2. So we said that this graph was going to go right 3. So it went right 1, 2, 3, and then up 4. 1, 2, 3, 4. And that should tell us where that vertex is. So we got it. And it's upside down because it was a negative, and it is a little bit narrower. Good. Now, as we do finish this one really quick, we're going to do our domain and range. So our domain, it keeps going left, it keeps going right, so it's going to be all reals. And now for our range, it keeps going down. These arrows go down, but they don't keep going up. So there should be a highest point. So my highest point is right here. I'm looking at my y. My highest point is 4. As I look at that 4, these numbers are below it. So I'm going to say less than or equal. All right, that is it. There is a quick check in Schoology.